Okay, I'm not going to do what I said I was going to do at the end of this. I'm not going to do a brief summary of this. I'm going to just go to the case where we have y equals b to the x with a doubling displacement of 1. Now, I don't want you to go back to this and use any of these inequalities as formulas. I want you to reason this out from the number 1. But then we'll see this and another example as instances of a formula and get a little better understanding of where that formula comes from, what it means, how it can be used, and of just what's going on with these exponential functions. So we have y equals b to the x with a doubling displacement of 1. And I'm going to indicate that this is a doubling displacement, and this is a doubling displacement. So that this distance is 1, this distance is 1, meaning that this is the y-coordinate, -1. Of course, here's 0, and here's 1. And what? If this is a doubling displacement, then the y-coordinate here has to be half what it was here, meaning this point is 0, 1/2, and this point here has to be twice as high as this point, meaning that this point is 1, 2. And it's not 0, 1/2, it's 1, 1/2. So let me see if I can make that right. Okay, so it's 1, 1/2. -1, 1/2. I'll get it right yet. Okay, so now we have, of course, the graph of the exponential function, which does something like this in this interval. So my question then is, we want to get an idea of what the tangent line slope is. The question is, what's the slope of this segment and what's the slope of this segment? Okay? So, well, the slope of this segment, you should figure this out on your own before I write it down, pause the video, whatever. But it should be very clear that the slope of this segment is 1/2. And the slope of this segment is 1. Okay? So we can say that the slope of the tangent line is between 1/2 and 1. So I can say one half is less than the slope is less than 1 for this tangent line. Now my conclusion is that the slope of the tangent line is less than 1. The value of the function, exponential function here, is 1. So the value of the exponential function is bigger than the value of the slope. So I can kind of write that down as a really important statement. I can say, if the doubling displacement is 1, then the value of the exponential function at 0 is greater than the slope and by that I mean the slope of the tangent line. I've got limited space here, so I'm not going to write out all the words. Okay, well, that's great. Now I want to do another graph for another doubling displacement. This time I want a doubling displacement of 1/2. Okay, so you should stop at this point and construct that graph. And I'm going to stop the video here and ask you to construct it before you read the next video, before you look at the next video or read any of the information I've given you. So you're going to do the same thing here, but your doubling displacement is going to be 1/2 instead of 1. So, I could write a little number on the doubling displacement here. It's 1, it's 1. Now you're going to draw the same picture, but this is going to be 1/2, and then you're going to do everything else that I did here and see what you conclude and see if you can make a statement analogous to this one.